All right, hi guys, this is Miss Kelly. Welcome to your first video of the notes for our digital learning. All right, so we are starting off our next topic dealing with inverse functions. And like it says, they're inverse functions with tables. We're going to be doing inverse functions for a couple of weeks and talking about the different ways that you can find inverses depending on how it's given to you. So looking at our first part of the notes here, it says the inverse of a function reverses or undoes the original function. Just like multiplication will undo division, subtraction will undo division. Those are your inverses. They undo what the original one has done. So when we talk about table values, your x and your y coordinates, all right, the x and y values are basically going to reverse roles, or in this case, switch places. They're going to switch roles. So that means the x's are going to become the y's are going to become the x's to make that inverse. Now, at the beginning of the year, we did talk about what makes a function, and we talked about how your x's cannot repeat. Okay, your x's cannot show up more than one time. So when we start dealing with reversing the roles and switching your coordinates, switching those x's and y's, the inverse of a function may not always be a function if the original one was. So just because your original is a function does not mean it's going to be the same when you reverse it. Now, inverse functions come with a certain kind of notation, which means it has to be written in a certain way. And when you see this way, that's your clue that you're looking at an inverse. And that's where you see in the next line there, that little bitty -1. It looks kind of like an exponent, but it's not having the same role as an exponent. So when we see the idea of your cursive f to the -1 power, you're fine. All right, it's not actually an exponent, because remember that cursive F, that bold F that's there is actually labeling what table you're looking at. So the -1 next to a label is how we denote an inverse. So just keep in mind, it's not F to the -1 power. This is read F inverse, or the inverse of the F table, or F mapping like we have here below. So when we see f to the -1 with the x in parentheses, we read it as f inverse of x. Okay, f inverse of x. So when we look at these two bubbles we have here, again, they're also called your mappings. When we look at these values, take a look at what's going on in the first f over on the left side. In the left bubble, you have the letters ABC. So remember we talked about domain and range a while back? So that in fact is my domain. While the second bubble contains the range. Now, when we bring in the inverse, because take a look at the next set of bubbles, that's where your little -1 shows up, denoting this is the inverse. So when we look at these bubbles, this time, check out what's in the domain. This time, those original range numbers, 1, 2, 3, are now in the domain spot. And the domain letters, ABC, are now in the range. So again, they switched. Okay, they switched places. That's one of the biggest things that inverses do, is they cause your x's and y's to switch places, to reverse roles. Okay, so knowing that, let's try some examples that we have down here below. So we have a table to complete. Okay, complete the table for f inverse of x. So I'm reading right here our instructions. So we have our initial table. We've got our x values listed. So here's our original x's. And we've got our y values, 5, 3, 1, -1, -3. So for us to get the inverse, Our goal is to switch those. We need to switch them. So that means we're going to have to take these x's and move them to the y column, take our y's and move them to the x column. They need to flip-flop on us. So for my new x's, I have the numbers 5, 3, 1, -1, -3. Those are the same y numbers that we had earlier. Those original y's are now my x's. Now my original x's make up my new y's. So -2, -1, 0, 1, and 2. So all they did was flip-flop on us. All right. So now let's look and see, is this new inverse that we just made, this new table, is it a function? So again, to describe functions, it's all about those x columns. The original one was a function because our original x's, none of those numbers repeated. Let's see if that's true for our new y's. I'm sorry, our new x's. So sure enough, none of those x values repeat. So we have a function. So is f inverse a function? Why or why not? That is a big old yes. It is a function. Because the x values don't repeat. Okay, if any of those x's repeated, then we would not have a function, because just when you break up with somebody, you don't want to repeat your x's. Now, let's talk about the domain and the range. So the domain of f of x, remember these were your x values. The range is always the y values. So let's go back up and look specifically at those numbers. All right, so the domain of my x are all of those highlighted in green on the left side. So -2, -1, 0, 1, and 2. Okay, so there's my x's, my domains. The y values are those ones that I highlighted there in yellow, 5, 3, 1. So I need the same curly brace. 5, 3, 1, -1, and -3. Okay, now we're going to want the domain and range of the inverse, because notice over there on the little -1s, now we want the inverse. So like we said earlier, the rule of an inverse is to switch roles. So that means my new domain is the same as the old range. 5, 3, 1, -1, -3. And my new range was the old domain, or the old x's. So that was a -2, -1, 0, 1, and 2. All right, so we're going to try just a couple more examples dealing with the same kind of thing, figuring out, do we have a function, yes or no? Can we get the domain and range, and can we actually identify our inverse? So let's check out the next page. All right, so same situation. Okay, complete our table to make G inverse of X. Now, notice this one's got a G instead of an F. Again, like I said earlier, that F was just a label so that you know what table you're working with. In this case, our label is a G, so we know that we're looking at the G table. All right, so let's see if we can do this one. Again, remember, we need to switch if we want the inverse. So my new X's are the old Y's. So that means that 41014 is now my new x's. So 41014. And my old x's are now the new y's. Because again, these two columns need to switch to make an inverse. So -2, -1, 0, 1, and 2. All right. So now let's see if we have a function or not on that new table. So is G inverse a function? Well, we have a problem because my 4's repeat and also the 1's repeated. So if you've got repeats happening in that inverse x column, then we don't have a function. So is this a function? No, it's not a function. So not a function because the x values are repeated. The x values repeat. Okay, so not a function. Now, we can still do the domain and the range. So again, our domain are the original x values, our range, the original y values. So let's see what we have. So domain of g of x. So that's this first original column for the x's. That's our domain. Our range, the original y's. All right, so our domain, we have a -2, -1, 0, 1, and 2. They need their little curly braces. And then we need our range, which is our original y column. So that's a 4, 1, 0, 1, and 4 again. And again, to make the inverse, those must switch roles. So my new domain is the old y's. So 4, 1, 0, 1, and 4. And my new range is the old domain. So -2, -1, 0, 1, and 2. All right, so hopefully we're feeling okay about these so far. So let's try another one. This time we're looking at some multiple choice, just trying to pick out which point answers the right question. So which of the following points must k inverse of x pass through? So again, k is just a label to make sure we're looking at the right table. So if we need to figure out which of those 4 points, A, B, C, or D, is going to be an inverse point. So we've got our original table. So I'm going to actually make my own table for the inverses. So I have my new x column. So that's going to be the old y's. So that's my 4, 1, 0, 1, 4. And my new inverse of x is my old domain. So -2, -1, 0, 1, and 2. So let's see which of these points now are in our multiple choice. So all right, so our first one, we have our letter A, 2, -4. I don't have that point anywhere. None of these values in the x's start with a 2, so A is out. A is gone. Now let's try B, -1, 1. All right, same problem. None of these x's have a -1 in it, so letter B is out. Letter C is also out for the same reason. There's no -1 in the x's. So now let's see our last one, 4, 2. There it is down there at the bottom. So there's our answer choice. All right. So let's do our last little bit, just a little more practice. All right, now, this time, guys, your points are listed in the problem. So we've got a blank table there that we'll use to record our original points. And in the second column, we'll use that to put in our inverses. So like letter A says, record the points that h of x will pass through. So let's go ahead and get our points in our table. All right, so we have the points -4 and 5. There's only 3 points, okay? -4, 5, -2 and 7, and 0, 9. Now, we've got a couple extra empty blanks there. That's fine. There's nothing wrong with that if your table's too big, if you've got some empty spaces. All right, so now to make the inverse, these need to switch places. So 5, 7, and 9 need to be first. And then our new y's are 4, -2, and 0 are second. So let's see, check your x's out, check those new x values. 5, a 7, and a 9, they do not repeat, which tells us we do have a function. So is h inverse of x a function? Yes, it is. That is a big old yes. So it is a function. Because the x values don't repeat. Okay, because your x values don't repeat. All right, domain and range, very similar to what we did before. Our original domain is our original x's, so that is a -4, -2, and a 0. And again, for the inverses, that is our new range. -4, -2, and a 0. All right, let's get your original range. The original y's are a 5, 7, and a 9. So for the inverse, those will become the domain. 5, 7, and 9. Again, biggest thing here, they have to switch places. All right, so number 5, our last one of the video, similar idea to the earlier problem. Your original points are listed there in the question. There's our original points highlighted there in yellow. We need to find the range of this inverse function. So like I did earlier, I'm going to set up my original table, and then I'm going to reverse those points, those numbers, so that I can get my range inverse. All right, so I've got my x column for the original, which is my 5, 7, and 9. My original f of x, my original y's. So a 3, -4, and -11. Okay, to make the inverse, reverse them. So my inverse x's will be the 3, -4, -11. And then I need my f inverse values for the y, which is a 5, 7, and a 9. So what I'm looking for in the answer, again, what is the range of the inverse? Which is the 5, 7, 9, which makes up letter A. All right, guys, that is the end of my notes. I hope you enjoyed it as much as I did, and don't hesitate to ask me any questions. I'll post tomorrow. I'll post later in the day when I will be online live. So if you have any questions at all, don't hesitate to ask. So make sure you're on the remind. I'll send out that reminder when I'm going live. Thanks, guys.